I appreciate the coordinator of the Science Cafe for giving me the opportunity to give this presentation. And thank you to our participants for joining us today to explore this topic that bridge the gap between mental health and the neurochemistry of N-Acetyl Cysteine, which is gaining ground in managing mental health disorder. So today we'll be diving into the potential of N-Acetyl Cysteine in managing mental health disorder. So my outline will cover talks about what mental health is, why is it of global concern, what are the examples of mental health disorders, the neuropathology of mental health disorder, the place of N-Acetyl Cysteine, and my research on how N-Acetyl Cysteine averts a model of neurodegeneration as well as models of mental health disorder. All right. Mental health disorder, using the World Health Organization definition, is characterized by a condition where there's clinical disturbance in individual cognition, emotional regulation, and behavior. And this disturbance is attributed to distress or impairment in functioning areas of the brain. What do I mean by functioning areas of the brain? I mean areas of the brain that controls emotion, that controls behavior and cognition. And I will dive into those areas of the brain. And when this mental health disorder occurs, it affects or alters behavioral patterns in individual, making the way a normal person should behave becomes to act irrational. Now, the prevalence of mental health disorder is of global concern because statistics have a report like 1 out of 8 people in the world is living with a mental health condition. So before, there were statistics brought out according to World Health Organization in the year 2019, giving a statistics of 970 million people are living with mental health disorder. And out of the varieties of this mental health disorder, we have anxiety disorder, which is an example of mental health disorder, and depressive disorder top the charts of the different types of mental health disorder. Now, when we look at the gender balance of people living with mental health disorder, majority of the people living with mental health disorder happen to be the female folks as compared with the male folks. And looking at the should I call economic status of country and their rates of exposure, incidence of mental health disorder, one can see that in the report of 2019, most of the high income countries, they have the higher percentage of people living with mental health disorder. Low income country is a bit lower. Now, fast forward to the data gotten during the pandemic, there was a sharp increase of cases of mental health disorder during the pandemic year, according to reports given by Santomaro et al. In 2021 from a Lancet journal. So now, looking at the age bracket, majority of the people, the incident rate is young people in the middle age, between the ages of 25 to 50, as are more exposed or more hit with this pandemic, with this mental health disorder of the class depressive disorder and anxiety disorder. And as we can see also, the majority of the increase is higher among females as compared to males. So, meaning there is sex disparity about incidence rate and incidence rate and exposure of women to having those mental health disorder. Now, so if you look at the statistics of the global conditions, disease conditions that will lead to disability or mortality, the mental health condition also top the charts. We have cases of diabetes mellitus, auditory problem, gynecological problems. Out of all the other problems, mental health disorder kind of is prevalent, depressive disorder, and we have anxiety disorder. So the global impact of this mental health disorder is quite high. So there's need for it to be an area of study to develop therapeutics to avert it while studying its mechanism of neuropathogenesis, why the incidence rate keeps increasing every year based on the statistics gotten. So the new global burden of disease shows that depression and anxiety is among the top health loss worldwide, and it has increased since the pandemic period. Now, we have different types of mental health disorder. So we have examples such as we have the major depression, we have the post-traumatic disorder, we have the bipolar disorder, schizophrenia, obsessive compulsive disorder, we have panic or anxiety disorder. Bulimia or anorexia is also called a eating disorder. Then the paranoia can be the panic disorder, like the anxiety disorder, bipolar mood disorder, and personality disorder. Those are examples of mental health disorder. And in general, mental health disorder basically are the disorder related to the mental state of an individual, and is attributed to changes in neuronal activity and function, and also attributed to changes in the neurochemical messengers, talking about the neurotransmitters in the brain. So we have, what are the areas majorly affected by this mental health disorder? The areas involve the prefrontal cortex, which is an area of the brain involved with cognitions. We have the hippocampus, which is area involved in memory potentiation. Amygdala, which is part of the limbic system. This area controls emotional behaviors. Thalamus is also part of the limbic system. So the thalamocortical neurocircuit, along with sending impulse to the hippocampus, contribute to forming the limbic system circuit that relates event of emotional or cognitive disorders. So these are the major part of the brain that are affected when we are talking about mental health disorder. So the major cause of mental health disorder, as described by the World Health Organization, is attributed to stress that disrupt the normal functioning of the brain areas I've mentioned. And this chronic stress, when it occurs, it affects the areas I've mentioned, the hippocampus, the amygdala, and the prefrontal cortex. And when it's affected, it changes the neurochemistry of the chemical messengers in the brain, which are basically the neurotransmitters. And when this event occurs, there's a way it disrupts the behavior, and there's a way it disrupts the emotional circuit, which has to do with reward, pleasure, happiness, and all that. And when it impairs this circuit through a condition in a model called aidonia. Aidonia is lack of joy from something that normally brings joy or happiness. It's attributed to one of the leading cause and signs of major depressive disorder. All right, so talking about the neurotransmitter in mental health, we have two classes of neurotransmitters. And okay, neurotransmitters are basically chemical messengers that controls neuronal signaling and function. So these neurotransmitters are either excitatory neurotransmitters or inhibitory neurotransmitters. The inhibitory neurotransmitters are the GABAergic GABA neurotransmitters, or that controls the GABAergic neurons, while the excitatory neurotransmitter are the glutamate, what's it called? The glutamate, adrenaline, and the other class. So the way this neurotransmitter operates is when it's being released from the presynaptic neuron, it activates the receptors of the postsynaptic neuron to facilitate any activity it needs to carry out, which it has to do with, if it's a GABAergic neuron, it activates a GABA activity, glutaminate, serotonergic, or any type of neuron it's being released. So most of these neurotransmission in mental health result in controlling sleep, neuronal homeostasis, signaling, memory, cognition, pain, feeling of pain, and emotion. So we have some class of neurotransmitters that kind of controls our mental health. One of it is adrenaline, and this adrenaline is produced in stressful situations, and the purpose as regards to mental health is to boost your environment, for how you are aware of things happening around your environment. Then we have the adrenaline, which affects your attention, makes you be at alert. Then we have another class of neurotransmitter, dopamine, which is the neuron involved in the feeling of pleasure. Most of these, that's what is studied for people that are going through this addictions research. That's the neurotransmitter. It's involved in pleasure and motivation. The neuron related to mental health also is serotonin, which is also called the happiness hormone. And basically because it contributes, is when there's a joyful hormone, so it's serotonin, it affects your mood and exposure. When you are in the light environment and you are just happy with the sunlight, that's one of the hormones that's been secreted. So we have the glutamate neurotransmitter, not hormone, and is the most common neurotransmitter that coordinates synaptic activity, creation of synapses, and also is involved in neural development. So we have also the endomorphin, but the hormones that we focus on mainly is the dopamine, serotonin, and glutamate neurotransmitters that controls the mental health. So how does this neurotransmitter affect mental health? Is either they are in high concentration in the brain or in low concentration. So for instance, when acetylcholine is high in the brain, it results in a case called depression. But when it is low, below the normal concentration, it causes memory loss, dementia. Another one is dopamine. When you have high amount of dopamine neurotransmitter in the synaptic cleft, it causes a mental problem called the schizophrenia. But when we have little amount of dopamine, it causes neurological disorder such as Parkinson's disease or an psychiatric disorder, depression. Then serotonin, which when it is too low, the happiness hormone, it results to depression. It results to depression, obsessive compulsive disorder when it is in low amount. Then another hormone, which is an inhibitory, another neurotransmitter, which is an inhibitory neurotransmitter. When you have them in little or low concentration, it results in psychiatric disorder such as anxiety disorder. So in some anxiety disorder, some antidepressants are basically drugs that helps to increase GABA neurotransmitter in the synaptic cleft. So this is how like I mentioned earlier, serotonin is an happy hormone. Low, it results in depression. Dopamine is also kind of an hormone that gives you pleasure of doing activities that result to reward. So here is the normal appearance of the synaptic junction or a synaptic cleft, where you have the presynaptic terminal and the postsynaptic terminal. And in the normal LD synapse that controls neural stimulation, we should have the receptor sites there, and as well as enough neurotransmitter released. But in case of models of mental health disorder, is either the receptor sites are low or the neurotransmitter secreted are few. And the condition that causes this is basically stress, as from my definition of mental health disorder, stress. And when this stress occurs, or any stressor occurs to the brain that mediates, that controls some chemical messengers that controls this stress, such as calcium signaling, and it affects the neurons, there's a way it also targets the receptors for this neurotransmitter. And the moment these receptors are targeted, it now prevents the presence of the normal concentration or activities of the neurotransmitter there, leading to the types of mental health disorder we have talked about. So basically, from that, you still go back to that definition, which is changes in the brain that alters the emotion, behavior, and all these changes are attributed to stressor that change the normal functioning areas of the brain. So what are the things that cause the areas of the brain mentioned, such as prefrontal cortex, amygdala, hippocampus, to function normally? The messengers for the brain, chemical messengers at the brain they are the neurotransmitter. So the moment there's abnormality in this neurotransmitter due to stress, we have the various types of mental health disorder as shown here. Okay, sorry. So based on the neurotransmitter involved, so there are various theories to describe mental health disorder as relates to the neurotransmitter involved. So we have dopamine theory, glutamate theory, and serotonin theory. And all these theories are attributed to the functionality or activities of the neurotransmitter in question. So for the dopamine theory, when there's an hyperactive dopamine at the dopamine receptor, that one can result to a type of mental health disorder, which is treatable by correcting the normal activities of dopamine. Then another mental health disorder attributed to glutamate is the one that has to do with NMDA receptor. receptor hypofunction. So when there is low glutamate within the synaptic cleft, so that's the glutamate theory. And for that activity to be normal, like increase glutamate activity within the synaptic cleft, you have to treat that one using the glutamate theory. Then another one called the serotonin theory, due to hyperfunction of serotonin in the cortex. And most antidepressants that are often used, they are the antidepressant that target the serotonergic pathway. Basically, they are called for instance, fluoxetine is a serotonin in SSI receptor inhibitor. So that's the function. So there, instead of reducing serotonin, it helps us inhibit the reuptake of serotonin so that the happiness hormone can be activated within the synaptic cleft. All right, so another pathophysiology that one needs to explain as per how mental health disorder occur is one, is stress. So we have psychological stress and physiological stress. We have different types of stress that can alter the normal function of the brain, psychological stress and physiological stress. And these two stress alters the activities within the brain. One of the activities it alters is one, it alters the immune response system that activates neuroinflammation. And oxidative stress and neuroinflammation, they work hand in hand. So the moment there's a stressor, the response is for inflammatory cascade reaction to occur. So one of the things that will occur is activation of the hypothalamic pituitary axis that activates the stress hormone, like the cortisol hormone. Then following that, there's an activation of the inflammatory response, the cytokines, pro-inflammatory mediator, interleukin-1 and all those ones, that shows that, okay, there's an inflammation as a result of the oxidative stress. And the moment this inflammation occurs, the brain begins to react. One of the things that happens in the brain is an interaction between the neuron and astrocyte. And that one is through mitochondrial dysfunction, calcium signaling that causes glutamate-induced excitotoxicity, that leads to loss of neurotrophic support and alter intracellular signaling controlled by the mitochondria, and thereby alter the synaptic protein, alter the activities of synaptic protein. Those are the things that occur. Then when all these things occurs in the normal functioning neuron, it now affects the cell, the neurons, whereby the neurons that should have their normal neurite cytoplasmic extension being connected to the next through the pre and post synaptic terminal, the neuron becomes atrophied and the neutrites begin to lose their strength, and then leading to loss of neuron, loss of the process of neurogenesis, production of neurons, loss of synaptic function. We also have cytoskeleton destabilization. What are the cytoskeleton within the brain? Those are the neurofibrils. They are lost. And what happened to the brain as a whole? The brain now lose. There's a way the brain's reduced in structure. And this reduction in the brain size attributed to cell atrophy and loss also decrease neuron glare function, the normal neuron glare activity, and also decrease neuron connectivity, which is synaptic connection is indicated by the protein synaptophysin. So when all these things has happened due to stress-induced mental health disorder, it changes the neurochemistry and the functions in the brain. And one of these things, as you see here, is translated to what we mention like imbalance between neuron glyph function, whereby glutamate metabolism or excitotoxicity we talked about is affected. If increased inflammatory response occurs, then neuroplasticity also occurs. Is that taking? All right, so the neuropathology of depressive disorder, neuroplasticity of depressive so the the neuropathology of depressive disorder, from the stress-induced mechanism that we described, now causes loss of neuron, enhanced neuroinflammation, increase pro-inflammatory cytokines, and which results into loss of neurons. All right. Now, so because of all this prevalence and the changes in the brain normal chemistry as a result of stress, one needs to bring out new treatment approach or pharmacotherapy that will be used to treat mental health. Because as I mentioned earlier, the current one most often used is selective serotonin reuptake inhibitor, which is the fluoxetine, and this fluoxetine targets the monoimmune system. But the side effect about this drug is that it has delayed response time as compared to other therapy. It has delayed response time. Now, so that's now why we now come to the biochemistry of this active compound, N-Acetyl Cysteine, which is described as a novel, which is not quite novel, but research is still ongoing on its novel approach with its potential benefits. So generally looking at the N-Acetyl Cysteine, or NAC, it has a lot of therapeutic activity attributed to the biological activities in studies reported. And one of it is that it has been used to treat lung diseases, liver disease, male infertility, high, and all these treatments are attributed to its antioxidant property. So since antioxidants, anything that has antioxidant property has ability to reverse the redox status due to oxidative tissue damage or stress. So it has been reported to help in neurodegenerative diseases and psychiatric diseases. So these biological activities or potential as regards to mental health is because it has the ability to eliminate reactive oxygen species released due to oxidative stress or oxidative tissue damage. It can also boost the antioxidant enzyme status by being a precursor for production of glutathione, which is a strong antioxidant compound. Because when the biochemistry is broken, that it produces a substance called cysteine, and that cysteine is described as a precursor for glutathione secretion synthesis. It can also be a precursor for glutamate production by mediating glutamine being secreted from astrocytes. So when there is oxidative stress here, and the glutamate that should be released for activities of neuron is not, there's an interaction called neuron-astrocyte interaction that now mediates the astrocyte to now activate its function, such as in producing antioxidants by itself, helping to boost the immune response. And all this process now end up repairing an injured neuron as a result of oxidative stress. And one of the factors is that astrocyte can now on a normal day produce its glutamate, but N-Acetyl Cysteine can still help in that measure. Let me just go over this mechanism. One of the mechanisms we focus on is antioxidant mechanism of N-Acetyl Cysteine and anti-inflammatory agent. One of the is that it suppresses activation of cytokine production. And since it can do this function, meaning it has pro-inflammatory, it's an anti-inflammatory agent, it can reverse or mop up any toxin being secreted when this stuff is there. So it can reverse or suppress production of this cytokine. It can reverse or suppress production of cytokine. Another thing is that it can also help us to regulate glutathione synthesis. So meaning it has a direct and indirect antioxidant activity. And one of the activities I also mentioned is it can control astrocyte interaction, inflammatory mediator, decrease inflammatory mediator, which also decrease oxidative stress and decrease mitochondrial dysfunction by acting on the calcium signaling pathway. Okay. So the precursor for cysteine is a precursor for glutathione synthesis. So what is now the end function of glutathione? Because we are starting from talking about N-Acetyl Cysteine. When N-Acetyl Cysteine is metabolized, it breaks down to cysteine and another compound. And this cysteine is a precursor for glutathione synthesis. And glutathione has been described as a potent antioxidant. So what are the benefits of glutathione to mental health? It improves mental focus and clarity, improves quality of sleep, and reduces the effect of stress. Amongst other oversight functions it performs. These are the functions it performs on the brain. So we are seeing a multifaceted function of N-Acetyl Cysteine. So based on this potential, we have reports. There's significant report on glutathione studies and how it affects mental health. Now, what's the role of glutathione in mental health? There's a study reported in 2011 that individuals with this disorder, schizophrenia, depression, and bipolar disorder, they have reduced glutathione activities in their prefrontal cortex. And don't remember that prefrontal cortex is one of the areas that controls these activities, that controls normal functioning of mood or cognition in the body. But when there's a disruption in their normal neurosignaling, it results in this mental health disorder. And from report, it shows that there's a decrease in glutathione in individuals with schizophrenia, depression, and bipolar disorder. This is the control, and schizophrenia, bipolar, and a major depressive disorder. Now, I did a study on N-Acetyl Cysteine to study effect on neurodegeneration. And one of the characteristics of the hallmark of neurodegeneration is loss of neuron, proliferation of reactive astrocytes, which is an indicator of a pro-inflammatory activities in the brain. So for this study to be done, for me to create a model of neurodegenerative disease, aluminum, toxin, heavy metal has been reported to induce neurodegeneration, and heavy metals can be used to model neurodegeneration in animal model. So by giving N-Acetyl Cysteine orally, I observed that astrocytes astrocyte that is a immunohistochemical marker for reactive astrocyte or reaction to neuroinflammation induced due to oxidative tissue damage mediated by the aluminum I've given. I found out that there is more reaction of astrocyte, meaning the astrocytes are reacting to the assault, which is aluminum, to prevent cell death, but they cannot mop out the rate or the concentration of the aluminum assault. So that's why you are seeing the reaction of the reactive astrocyte. But upon giving N-Acetyl Cysteine, we see a decline in the reaction of the astrocyte. So there are emerging and continuous evidence of N-Acetyl Cysteine to be effective in managing psychiatric disorder because of continual research and investigation done by scientists. So one of the mechanisms that we can describe about N-Acetyl Cysteine to impact mental health disorder is that it modulates glutamate. It modulates glutamate activity. It enhances synaptic connection and activities within the pre and post synaptic site. It reduces inflammation reactions, and it has antioxidant property that boosts the glutathione enzyme activities in the brain. And one thing I need to say is that N-Acetyl Cysteine has been reported to pass through the blood-brain barrier to carry out this activity. So this is a schematic illustration to show you that N-Acetyl Cysteine can modulate the glutamate receptor activity. It also reduce inflammatory cytokines. Instead of seeing it increase, there's a way it's reduced by mopping out the free radicals, causing it to increase secretion of these inflammatory cytokines. But also, while mopping it out, the neurons are in a better environment to grow by controlling calcium signaling, mitochondrial energy activity that increase growth factor and increase neural sprouting. Then we have its antioxidant property by controlling glutamate cysteine ligase enzyme that now create glutathione synthase that boosts which is like a precursor for synthesizing glutathione from the N-Acetyl Cysteine. So here we want to see how its neurotransmitter effects and how it modulates redox modulation. What is redox modulation? It's like inflammatory response to reduction and oxidation activity as a result of oxidative stress that increase this production of reactive oxygen species such as hydrogen peroxide and all the other biochemical release during redox activity that will end up causing neuron damage. But when we have N-Acetyl Cysteine producing more glutathione or synthase, there's a way to increase this glutathione synthase and mop out the free radical generated, thereby reducing their generation and reducing the oxidative stress and reducing the cell damage. And also, there's a way to reverse this mitochondrial dysfunction. Instead of it, as it decreases the reactive oxygen species produced and giving out more activities of the calcium here, then there's a way it balances and averts increased calcium signaling that induce mitochondrial dysfunction or stress. And one of mitochondrial dysfunction can be attributed to mental health disorder. So talking about mental health disorder, for instance, taking depression, for instance, is there a correlation between mental health disorder and memory disorder? Is there a correlation between memory impairment disorder and mental health disorder. According to Yule and Lanzat et al. 2022, they described that there's a correlation between the two. The reason why this correlation is because there's a similarity between the neuropathological changes in neurodegenerative disorder and this neuropsychiatric disorder, attributed to changes in the structure of the neuron and the neurochemical deficit in this disorder that leads to episode of sadness, anhedonia, and reduced cognitive concentration, and also has something to do with memory. So there's a correlation between depression and memory disorder. So one of the correlations that can be explained is neuroinflammatory response. Neuroinflammatory response marked by proliferation of astrocytes or reactive astrocytes. And there are reports that said there's a correlation between expression of astrocytes and loss of synaptic connections or neural connections. When there's neuroinflammation, astrocyte proliferates, and this leads to another sign, one we see in neurodegeneration or mental health disorder, such as loss of synaptic connections. So when there's loss of synaptic connection, the neurotransmitter that should send information to the synaptic terminals are lost. So that one will now cause loss of memory and memory potentiation along the action along the neural circuit pathway. Along the neural circuit pathway. So I just want to dive into explaining a little bit of what happened in astrocyte neuron interaction in brain disorder. Our focus is mental health disorder. So it's similar to what I've explained earlier, that astrocytes are very significant in controlling emotion, learning, and memory, because they are like supporting cells into neurons. So when there's an assault to the neuron, they kind of activate cascade of reaction for repair, to modulate glutamate activity, to boost immune response. And they also act as indicator or biomarker to show that if there's an effective treatment for a neurodegenerative disease, like a biomarker, because they are neuroinflammatory markers. So if the inflammation is reduced, then the astrocyte activity would decrease. So when there's normal astrocytes controls normal cerebral function and controls the neural synapses. But when there's when there is assault to cerebral function, the astrocytes are affected. And one of the ways the astrocytes react is to disrupt neural synapses, increase release of pro-inflammatory cytokines. And also they are also involved in production of their own neurotransmitter called glial transmitters from their synaptic cleft. So there are a lot of reports over the years that has been used to target astrocytes as a cell in the nervous system to study the potential of novel antidepressants. You know, we have different mental health disorders, but now I'm just focusing on antidepressant drug. And when the astrocyte is being targeted, it's being targeted to see how it controls glutaminergic signaling and how it controls brain-derived neurotrophic factors, which are the two things that are modulated by astrocytes. So, to recap, the pathogenesis of a type of mental health disorder like depression, it is linked to neuroinflammation and oxidative stress. If there is a stressor, it will activate neuroinflammation in response to the stress. And when this neuroinflammation is there, it will cause release of biomarkers for a neuroinflammation which are interleukins. But the purpose of an antidepressant is to reduce or inhibit neuroinflammation, which also reduce the level of the inflammatory biomarkers and end up mopping out the stressor, which the stressor that mediates oxidative stress. So even if one wants to model antidepressant drugs, for instance, N-Acetyl Cysteine, one of the model use is animal models. And the animal, we have different types of animal models for behavioral despair test to study mental health disorder. We have the forced swim test for behavioral despair. And we have the tail suspension test for anxiety disorder. So for a study I did on N-Acetyl Cysteine, I did the behavioral despair test, which is the forced swim test. And the procedure for the forced, and for me to test if the compound has antidepressant activity is that an antidepressant will reduce immobility time, meaning the time the rat is standing is in the water, immobile will be reduced. So my study dose is 20 milligrams per kilogram body weight of N-Acetyl Cysteine. And for me to see if this N-Acetyl Cysteine is effective, I use a standard antidepressant drug, Prozac, also called fluoxetine, which is mostly prescribed at 20 milligrams per kg. And so my FST test is a short validity test to see if N-Acetyl Cysteine is a fast-acting. Remember I told you that we have other drugs for antidepressant, but the problem with them is that they have delay response time. So the patient will be on it for a long time before the symptoms will be emanating. So for this, the short validity test was for 3 days. And at the end of so the procedure is, there will be a 15 minutes FSC, forced swim test, arbitration test for 15 minutes. Then I will now put them through a 5-minute pre-test. Then I will now put them through the actual 15-minute test for the forced swim test, which is the one. So this is the one recorded as the stress exposure time. So all this one is the pre-test. When you are doing behavioral study, you have to arbitrate them to the condition. So this is this is the arbitration, and this is the pre-test, and this is the actual test. So when we now induce this test, then I will now give the rats the antidepressant, fluoxetine, or my novel drugs that I'm saying it will avert a type of mental health disorder, which is the N-Acetyl Cysteine. Then after that, I will now expose them to a stress to see if the stress, these drugs will have beef up the neurochemistry to fight against the stressor. So what I observe from this study is, for the forced swim test model, they have increased immobility time, which is a sign that they are depressed. They have low cognition, and they have poor emotion about the situation around them. They are depressed, so they have more immobility time in the water. Their mood is not, they are not themselves in the environment they are placed in. But however, fluoxetine shows its normal antidepressant activity by acting on the serotonin pathway, causing the animals to have reduced immobility time. So my test result drug, which is N-Acetyl Cysteine, also has the potential to reduce immobility time. So when comparing with this one shows that, oh, N-Acetyl Cysteine acts like an antidepressant by reducing the immobility time. So now, testing for sucrose preference test, which is for anhedonia. You know, when the rat has passed through stress, you make them go through exposure to dual bottled water, one with sugar solution and one with water solution. If the animal is still having a reward circuit coordinated, the animal will be interested in drinking sweet water, which is sucrose water, as compared to normal water. So before this is the control. So this is the depressed animal model. Before, they all drank the 15 minutes and a day before, they all drank the sweet water. But a day before, they still drank this. This is the pre-test. These are the rats without the pre-test. So the people with the pre-test, it's reduced. So in the real 5-minute test, it was low as compared to the depressed rat. So you will see the depressed rat B has a lower sucrose preference as compared with the fluoxetine treated, N-Acetyl Cysteine treated, and fluoxetine treated. Even after exposure to the depressive condition, fluoxetine and N-Acetyl Cysteine alleviate anhedonia status in the rat. Now, looking at the expression of astrocytes, proliferation of astrocytes, for the N-acetyl, I'll focus on, this is the control. Then for the N-Acetyl Cysteine treated depressed rat, one can see there is the astrocyte. These are the brownie deposition of astrocyte. We see have the astrocyte being expressed there just to protect the neuron and do its normal protective function there. But you can't compare it with the darkish brown pigmentation of the reactive astrocyte in the depressed group. So in this reactive astrocytes here are reduced as compared to the FST or the depressed animal model. Now, then staining for the synaptophysin, which is a protein showing the synaptic activity. Synaptic activity, and the neurons will be, the neurons nucleus, that's what we are seeing as blue. So here you see a lot of pycnotic or lost neurons, and these are the normal neurons with few pycnotic neurons in the depressed model, post-treated with N-Acetyl Cysteine and fluoxetine. So one can see here that we have diminished poor synaptophysin in the neuropil as compared to the brown deposition of synaptophysin here. So meaning fluoxetine and N-Acetyl Cysteine improve synaptophysin activity, as reported that when there is reduced astrocyte activity, we have improved synaptophysin activity. So here it shows that N-Acetyl Cysteine can alleviate depressive substance and symptoms by acting as an anti-inflammatory biomarker for astrocytes, mopping out the free radicals and improving the glutamate base, while helping to improve or increase synaptophysin activity. So this one is also seen in the hippocampus. This is the hippocampus and in the cerebellum. The reason why cerebellum, hippocampus and cerebellum is doing is because of coordinated memory for locomotion. Cerebellum has to do with locomotion. Hippocampus has to do with memory. So we have the same response, just like activities of synaptophysin. Synaptophysin activity improves synaptic connection that improves immobility time in the fluoxetine and the N-Acetyl Cysteine treatment group. All right, so we have a lot of reports that have documented how N-Acetyl Cysteine averts mental health disorder using this mechanism of improving neurotransmission, maintaining oxidative homeostasis, and controlling inflammatory mediator. But before any report on N-Acetyl Cysteine is done to clinical studies for the general population, there will be a pre-clinical trials. Then there will be a control clinical trials. So from this report from Arena et al. And co. in 2021, for the various types of mental health disorder, talking about the attention, ADHD disorder, anxiety disorder, and the other form of disorder, there is no preclinical trials for this based on their reports, but we have one randomized control trial for clinical, and that one gives a positive outcome. So for the anxiety, we have 15 reported cases of preclinical trials and 11 give positive outcome for anxiety. But for anxiety disorder, none has been given for human subjects for post-clinical and clinical trial. Then looking at the depression study using animals, 9 out of the preclinical trials on rats, 8 gave a positive response. Then out of the 3 clinical control trials, only 1 has a positive response. So meaning there must be continuous study on this so that it can now be reported for human as, instead of 1 out of 3, then we should have more numbers studied here. So we have some areas that have not been studied, and we have areas for schizophrenia. We have 17 has been preclinical trials from their own data, 12 are positive. But we know when you go on the internet, you see a lot of researchers reporting their studies on N-Acetyl Cysteine and psychiatric disorder. So there is a correlation between mental health disorder and neurological disorder. An example of mental health disorder is depression, and a neurological disorder is memory disorder or Alzheimer's disease. This is because the degeneration of the neuron disrupts the same functional areas of the brain that controls mood regulation and cognitive response. And so these areas of the brain are hippocampus, prefrontal cortex, and amygdala. So amygdala has to do with emotional memory. So that's why it has something to do with correlation with depression and memory disorder. So in conclusion, I'll say N-Acetyl Cysteine has antioxidant and neuroprotection potential, which enables it to modulate glutamate deregulation, modulate oxidative stress, as well as neuroinflammation through neuron-astrocyte interaction. This results in ameliorating neurobehavioral impairments seen in mental health disorders such as schizophrenia, obsessive compulsive disorder, and mood disorder. Examples are depressive disorder and anxiety. So I want to appreciate Science Cafe for inviting me to give this talk. It's a privilege. I'm not taking for granted. I thank the coordinators for the Science Cafe. You are doing well. Mr. Wet Okuti, I hope I get your name right. And thank you for listening.
Wow, wow, wow. Thank you so much, Dr. Memudu, for that wonderful presentation. It's really enlightening. I got to hear some things for the first time, learn about your research too. That's really, really great. Now we can start asking questions. So it's either we drop the questions in the chat box or we raise our hands and then I can call on us to speak if you choose to speak. So I think someone raised his hand. I'm trying to look for him again. Read one. I think I saw you raise your hand. All right.
Just read out the questions so that I'll answer them one after the other.
Okay, man, like he raised his hand to speak, to ask the question himself. That was
Okay.
Good evening. Good evening, ma.
Yeah, good evening.
Okay, thank you very much for the wonderful presentation. My question is a little bit just for me to get the grasp of of the entire presentation. So, you made mention of the first thing about psychological stress and how it can lead to and how it can lead to mental health disorders. And then you made mention of oxidative stress. So I wanted you to maybe expatiate or a little bit just tell us about how exactly, or if there is a molecular mechanism of how psychological stress can lead to oxidative stress.
All right.
Or is there a difference between psychological stress and oxidative stress, or are they the same thing? Or is there a difference between both of them?
No,
So,
psychological stress. Psychological stress. Can you, am I muted?
okay.
no, I can hear you, I can hear you.
Yeah. Psychological stress is the stress that affect the normal activities of the psychology of your mental cognition. And this psychological stress, one of the factors is environmental factors, workplace, social environment, isolation. So those are the things that causes psychological stress. Then physiological stress are caused due to hazards. You know, I mentioned that there's some things around you that causes some emotional stuff. And when it affects you, maybe let me use the word toxins. There's some toxins that can induce stress and affect the normal chemical signaling in the brain. So that's why one is physiological and one is psychological. But at the end of the day, all these class of stress still affect the brain. Is that taking? And when they affect the brain, both of them still affect the brain by causing oxidative stress. What is oxidative stress? When the normal homeostasis of the nervous system, which should be reduction, oxidation reaction, controlled by mitochondria. When there is an imbalance, that we have more of oxidation or pro-oxidants within the system that leads to production of reactive oxygen species, hydrogen peroxide, nitric oxide, and all these things. Those are the things. So the condition, such as oxidative stress, are the ones that act like pro-oxidants that cause oxidative stress. And when this oxidative stress are happening, it now leads to this creation of reactive oxygen species. When the reactive oxygen species are there inside the brain now, nervous system, it breaks the membrane. It causes the membrane that should be, you know, we have cell membrane that is double cell membrane that should be fluidy in nature. It's breaking leaking out the chemicals talking about the malondihyde enzyme, which is most of the biomarker for lipid peroxidation. So, but at the end of the day, both stressors also just come together like why to now activate the oxidative stress process that I mentioned, like and when the oxidative stress has now been affected, you now see events like neuroinflammatory markers, cytokines increasing, you now see astrocytes proliferating, you now see the glutamate responding, because this oxidative stress is controlled by the mitochondria. Then the mitochondria is abnormally working. We now call it mitochondrial dysfunction, and it's a metabolic disease. It's a metabolic disease. So you now call this type of disease can also be classified like a metabolic disease because it affects the normal metabolism in the body. I hope I'm not good. I hope you get what I'm saying.
Yes, ma. Yes, ma. I understand, ma. Can she hear me? Yes, ma. Thank you very much, ma. I understand perfectly, ma. Thank you.
All right.
Thank you very much, ma'am. So we'll be moving to the next question, and I'll be reading the of the high incidence of mental health disorders in high-income countries, looking at the fact that the economic situation is okay and they have the wherewithal, they have the resources to alleviate depression and live out their happy life.
Yeah, when I saw the report, I was amazed too. One time the income in the country would be high income, but if the respondents are responding that they are positive for the mental health, you will take it like that based on the respondent. So what I can say, they might be high income earners, but the economic condition of an high income earners will not be balanced. For instance, we have high income earners in Nigeria. Let's assume that Nigeria is an high income country, but we have some economic crises that are happening within that period. There and if you check the result, I think it should be pre-COVID. And if there's inflation, even though the income is their high income country, the inflation rate might also affect them to be depressed. So that can be the reason.
Okay, ma, thank you so much, ma. So
all right.
I believe the question is well answered. So we'll be moving on to the next person that has his hand raised up. That's Nasruddin. Can you ask your question, please?
Yeah, good evening, everyone. And thank you, Doctor. Yeah, thank you, Doctor, for taking us through the brain anatomy, physiology, and biochemistry tonight. I really enjoyed the presentation. Yeah. Actually, I'm also one of your followers on Twitter, so it's nice listening to you tonight.
Thank you.
So I have some few questions.
All right.
Yeah, number one, considering the global burden of mental health, what's your advice to students that normally engage in TDB, the daybreak reading, who indulged in caffeine and nicotine abuse? For example, mixing Coke with Nescafe or eating cola nut with Lipton, putting in mind that these substances inhibit acetylcholinesterase, which leads to continuous excitation of acetylcholine. So what's your advice?
I will advise that they should discontinue that habit. I did a work on that, and the report is not impressive. Studying the effect of combination of caffeine and one other psychostimulant, it over excites the brain. And when there's a way you would study the latter dose to see the effect. There's a way when a student wants to be awake, they take the high concentration so that they will be awake.
Yes, ma'am.
Yes, and two things about how drugs affect the human body. The genetic composition of individual varies. That's why the field of neurogenomics is now coming into play. that there's some things you take that affects subject X and subject Y is not really affected, but they are the same human being. So what's happening? That means there will be an epigenetic pathway that's altering it. But on a fundamental base, it is hazardous to the mental health for students to be taking two core psychostimulants together. And I trust it will be in high dose. So it is not good for their health. It will cause over-excitation of their brain. They will be so alert that when the time for them to rest and sleep comes, that sleep will not come because the neurotransmitter for alertness is also already pumping. You know, we have a normal neurotransmitter for alertness, and that will now reduce for sleep reading to come. But when you now drink all these psychostimulants, it blocks the sleep hormone. Sorry, the sleep neurotransmitter that controls sleep and relaxation. So even though the student wants to sleep, the brain will be pumping, and that's why most times the brain will become overexcited. The neurons that should coordinate them to read, you know, there's a way you have read yesterday and you now took the drink today. The neuron that should potentiate this memory potentiation for recall and stuff will be deactivated. So the student will be in the exam hall, will not be able to recall what they've read before consumption of, what's it called? The nicotine, causing a short time, retrograde amnesia, whereby you see students coming to the exam, all that. Those students that are really affected, that has gotten to the peak affecting them, they lose their memory for that exam. They are not coordinated. Their cognition stuff is lost. So most times you see them rushing them to the hospital. Maybe at times they give them a lot of infusion to flush it out of their system. So for me, I will advise students to check their reading pattern, know when it's good for them to read, and they should not over abuse psychostimulants, thinking that it will keep them alert and they will read longer. So that's what I will advise the student to do.
Oh, thank you very much, man. Actually, I was a day during the exam, I was sitting with a guy. Immediately, he saw the question. He just murmured, "Oh boy, another carryover." And my brain also went, yes, and my brain also went blank due to the word he uttered. So I had to stay for 20-25 minutes before I could record that day.
Yeah, because you are shocked. Because what he told you, you have the social relation, this social it's not the word interaction. You know, when someone is having a problem, there's a way you empathize that you say you lose balance before you now get your footing. Something like that.
Yeah, yes, man. So the second question is, so why the choice of only male rats in your research, considering that you made mention that the female are more affected than the males?
And you know, what I was studying is the mechanism, because there are reports that have studied sexual dimorphism in treatment, but right now my next research will include looking at differences between male and female. But as at then, I was just studying the mechanism, because most reports show that there's sexual dimorphism, which is, we know there's sexual dimorphism because of the hormones in female, and some hormones that are not in males. And because it's basically hormones, most of the things, the disparity in stress in male and female is associated with hormones, based on my studies.
Oh, thank you. Sorry for taking up your time. The next one is there
for
any
future
effective...
study, you want to do comparative study? No.
All right, all right. So the next one is there any effective dose for this NAC presently to avoid substrate inhibition of the target site?
Yes, there are those. For me, I've forgotten, but so a study has done the lethal dose 50 and found out that there's a particular dose that's very toxic that some rats died. But based on his report, I use his own therapeutic dose, because what I'm looking for is a therapeutic dose that can affect that can improve mental health. So that was why I just adopted this 20 milligram per kg therapeutic dose. And I've used 1,000 milligram per kg and the rat survived. But based on that person's report on neurocognition, and again, I was studying it along with another dose. I want to use the same dose. You know, that study I conducted was therapeutic dose for Prozac, fluoxetine is 20 milligram per kg, based on the study I saw. So I decided to, okay, let me use the same dose so that I will not go and use higher dose of N-Acetyl Cysteine and it will work. So let me use the same dose. So when I use the same dose, I observe that the same effect I see in fluoxetine, I see it in N-Acetyl Cysteine. But in some cases, the fluoxetine has better effect as compared to N-Acetyl Cysteine. So in future research, if I increase the dose on N-Acetyl Cysteine, maybe the effect now will be more potent as compared to fluoxetine, that is the studied dose.
All right.
I'm
Thank you very much.
All right.
Okay, ma. Thank you so much.
Thank you very much.
So yeah, I was going to move to Abdulaziz, but speaking of those, I think I have a question that I think we could just quickly address now, since we're still talking on dosage. I wanted to ask about if NAC has any adverse effects or potential toxicity when the concentration is high in the body system. Looking at the fact that, you said it has been studied or it has been found to cross the blood-brain barrier, and then that is a very, very delicate part of the body system.
Yeah, that's what I'm saying, that the LD50 was toxic. I can't recall the dose. Well, you can check for it on the internet on research. It has its LD50 that's toxic. And again, yes, it has the LD50, but it's toxic, but I can't recall the toxic dose. And one thing you need to know is that, all the drugs we use, they have their side effects. It's hard for you to see a drug that is just there without side effect. But the issue is, before you get to the side effect, there's also a therapeutic effect there's a drug pharmacokinetic curve that when there's a way it gets to its therapeutic effect and it declines and all those stuff. But I can't recall, but I know that if anything taken in excess will have a toxic effect.
Yeah, ma. Thank you so much. So, Abdulaziz, you can ask your question now.
Hello, can you hear me?
Yeah, clearly.
All right. Good evening, everyone. Thank you, Dr. Adejoke, for the explanation. It was just the perfect CNS pharmacology refresher course that I needed. And apologies if you probably mentioned this along during the presentation, maybe I missed it one way or the other. I'm just curious. I think you mentioned that this NAC is a precursor to glutathione.
Precursor to cysteine, yes, and precursor
and
to
then
glutathione.
Eventually to glutathione. Oh, okay, all right. So I'm just curious. Is there a specific advantage is there something unique about this particular compound, considering the fact that glutathione is already existing as a supplement? So is there a particular advantage that it has, maybe,
it has an advantage.
Or,
for me,
advantage that it will have on the existing glutathione? Because if eventually it's going to be leading to glutathione, which has been existing before, I'm just trying to, maybe the synthesis is just better, or, like I said, you could have mentioned it along the presentation that I
Yes, N-Acetyl Cysteine. The reason why it's described as a potent antioxidant is when you consume it and it's being metabolized, is broken into two bioactive compounds. Is it in the liver? There's a liver metabolizes drug. It broken it into two active compounds, which is the cysteine. There's a chart for it. Cysteine and one other compound is broken into cysteine and glutamate. Then cysteine is now the precursor that undergoes another metabolism or acetylation. No, it's not acetylation. So let me not use the wrong chemistry term. It also undergoes another active chemical reaction to now turn to glutathione. So apparently, what N-Acetyl Cysteine is that it is a mini glutathione on its own. So if you can't afford a glutathione, you can buy it. It can give you two things. It can be broken down into cysteine and glutamate. The glutamate is a neurotransmitter on its own. The cysteine is now a precursor that will form a neuroprotection, which is glutathione. So it's potent than glutathione.
Okay.
You don't understand? N-Acetyl Cysteine, when it's broken down, it can yield glutamate and cysteine can now be broken down to glutathione through glutathione synthase.
Okay, all right, thank you. So basically what you're saying is that using NAC would just it's just lead to the production of two different neurotransmitters, which using glutathione.
No, glutathione is not. Glutathione is an antioxidant.
Yeah. Oh, okay.
Glutamate is the
neurotransmitters. Oh, yeah. Okay.
And cysteine is an amino acid building block.
Yes.
That will build you another amino acid protein block, which is the glutathione protein antioxidant. And from there, you can now form glutamate.
Okay.
It's a neurotransmitter. So it has a lot of activity. When it enters the body, it can divert and control glutamate activity that controls excitatory neurotransmitter activity. Then this glutamate, when it's being produced, because it's now increasing, we have normal glutamate being produced in the astrocyte. So imagine you bringing another something that can increase your glutamate production. So if there's a way it can relieve the activities of astrocyte by boosting the glutamate level, so that the astrocyte can rest from their reaction to the neurotransmitter neuroinflammation. While the N-Acetyl Cysteine is also producing glutathione, mopping out the free radicals from the environment on the neuron that is relaxing from producing glutamate to fight against to control glutamate modulation in the brain.
Okay.
For example, impulse conduction.
Okay, thanks.
Thank you so much, ma'am. That is really, really explanatory. We have a question in the chat box, and Chamberlain is asking.
Glutathione being used as a bleaching component now. Glutathione is an antioxidant. There's a way it repairs the skin cells, repair everything. So that skin cell is just, for me, I would say glutathione is just to brighten and protect the skin from toxin and everything. And there's a correlation between melatonin, and skin pigmentation. So when glutathione comes in, there's a way it controls that melanin shock. That's why it appears like a bleaching agent, but it's not bleaching, just kind of, should I use the word tone so that I won't be too hard on people that are using it for skin treatment. So it's not really abuse. It is in the course of using it as an antioxidant to regenerate the skin that it's not producing its activity of reducing melanin pigmentation through I hope it's there's one pathway it coordinates that involves melanin and everything that reduce the pigmentation in the skin. For the person asking about bleaching. I hope I've answered that question a bit, but you can read more on it, but that's just the glimpse I have about it when I read something about it as for skin treatment. All right.
All right, thank you very much, ma'am. For the sake of time, we'll just quickly take the existing questions we have, ma'am.
Okay.
If that's allowed. Okay, ma'am. So Chamelin is asking if NSA could relieve a schizoid, like basically the status of or the condition of being antisocial.
For schizophrenia.
No, schizoid, like being antisocial, like trying to dodge social interactions and all.
Yes. It's been studied that it can be used to alleviate anything that has to do with mood disorder. Yes.
Okay. Great, ma'am. So we'll move to the next one.
So that's why, sorry, if you go to some, this system is being concentrated as I'm sorry, what's it called? It's concentrated as capsules or even capsules and tablets, like nutraceuticals in pharmaceutical companies. In pharmacy, if you go to all those expensive pharmacy, not the normal pharmacy that you buy your PCM, you see those drugs, and where you price it is quite expensive. So it can be used for managing anything that has to do with mood disorder, social behavior, even people suffering from addiction. They've used that treatment. And for people that don't randomized trials, it's been reported as being positive.
Yeah, thank you so much, ma'am. So just a brief announcement for the members in the group. The link to the attendance for today is in the chat box. Please let's follow the link and fill the form. Yeah, thank you so much, ma'am. So I want to ask, ma'am, like I did some minor stalking on your ResearchGate profile, and I saw that you work on apps to more like phytochemical aspect of this. So generally, like when people work on apps, medicinal plants and fruits and all, the conclusion is either the discovery of some compounds or some molecules or extracts that could have some biological activities. And secondly, to encourage sometimes the ingestion or consumption of such fruits that have such compounds. So I want to ask if there are natural sources of NAC, and because looking at your doses too, I see that can people get that much NAC from fruits such that it's beneficial to them, looking at also the pathological aspect of this mental health disorder?
Oh, thank you for that question. We have NAC in fruits. We do have, if I can recall, we have them appearing in fruits like those berries. But the concentration for you to be exposed to say, okay, I've taken 4 milligrams for my kilogram body weight, or I've taken this concentration, might not be there for you to know. But what I can advise is, there's some way you can go on the internet based on all those people that do the chemistry and say one orange is equivalent to maybe 5 milligrams of vitamin C. There's a way all those dietitians and nutritionists have done some average calculation based on that. So if one wants to get exposed to N-Acetyl Cysteine from the fruits, it would be good for you to just find out how many berries will you eat for you to get N-Acetyl Cysteine. Okay?
Okay. Yes, ma'am. Thank you so much, ma'am. And then lastly, so we could release Uma, we want to ask one more question, ma. And that is from Dolapo, and he's asking he's of course commending the interesting statistics in your first slide, and also asking why post-COVID women had more mental health issues compared to men. In your opinion, what do you think caused that?
Okay, that's what I'm saying. It's hormone. You know, when for me, for women, I would say one is general. For me, not to be biased, the baseline is hormone. The hormone in woman is different from male. Number two, you know, there's this report like changes in hormonal changes attributed to stress in women, and this one has been linked to the stress of the neuroinflammatory response in the monthly cycle and in hormonal changes. So everything has to do with hormone. That's the first thing I will report, hormone. Then if I now want to go to activities of the care and the burden of a woman, either, let's say, a family woman, if you look at the age bracket for the statistics, so if it's a mother in childbearing age or a working class woman, or so all those prospects for all those activities held by women contribute to the increase in anxiety rate and depression rate for women. And one of the things that they mention is this postpartum depression. Do men go through postpartum depression? That would be a plus. Why why the indexes for women depression increase. So if they capture a woman in a postpartum depression in the statistics, I'm just saying that's one of the things aside from hormones. So everything has to do with hormones. And the postpartum depression is also linked to hormone. So the baseline is hormone, either workload or something is hormone. So the N-Acetyl Cysteine, as I mentioned, can be found in yogurt. You can find it in fruits. You can find it in legumes. You can even find it in eggs. Anything that is having tryptophan base, milk, egg, cheese. That's where you can find the cysteine or N-Acetyl Cysteine and fruit.
Thank you so much, ma'am. Like I see that the last question that I wasn't even going to take because of time. I was going to apologize to Ikenna for not taking the question, but thank you so much for taking that question already. Thank you so much. So we've come to the end of the presentation. We can't thank you enough for honoring our invitation to tell us about what you do, and then of course to give us from your wealth of experience and from your